Yeah, Mark.
Oh, hi, Steve. Hi, John. I'm gonna give people a couple of minutes to join. Just a couple more minutes.
If I may ask, prior to formal meeting kickoff,
Yeah.
I've been lurking, and I really appreciate the hospitality of you guys allowing me to lurk and listen and learn. But one of the things that I'm really confounded by in all of the confidential compute stuff and the attestation and all the proposals and whatnot is the centralized single points of failure of trust upstream. It all resolves down to a single entity and whatnot. And I'm wondering, is anybody? I'm coming from the Web3 world, and in particular, a couple of big storage networks and whatnot, and decentralized permissionless trust of blockchains and whatnot. Has that been a spike topic for folks to explore? And I'm thinking in particular some of the breakthroughs that were done, like with the Cubic chain right now, being able to handle north of 16 million transactions per second. And when cryptographic identity can be absolutely verified, things like reputation on chain seems to me like a better path than a siloed certificate issuing authority that can be corrupted by state actors, by a variety of things.
Well, so are you talking about the fact that, for instance, if Intel TDX is compromised or Intel's signing key for endorsement certificate is compromised, that it's game over for Intel TDX? Is that sort of the concern?
Well, if a third party can't certify, yeah, if a and I'm being very generalized, very generic in all of the confidential computing topics, but at all of them tend to converge on a single authority to form the hierarchy of trust. And has it been explored that there might be some alternatives? And I don't mean to add noise, and if I'm interfering with the formal meeting.
No, that's fine. I mean, I don't mind spending a couple of minutes on it, especially the attendance is light today. So you need to first look at it from sort of the point of view of what the sort of confidential computing primitives really are here. So what makes confidential computing tick is this concept of a quote, right? So a quote is a signature by a microchip, right? By a key that's hidden in the silicon and not accessible outside of the silicon over a set of statements, right? The statements are about the chip itself and also about the trusted execution environment. So maybe the code pages of the trusted execution environment, and also some piece of information that the trusted execution environment holds. So now you can say, okay, on a chip we trust, and subject to some code that that's running on that chip inside a T, there is a piece of information contained, perhaps a hash of a public key, right? So something like that. And now you need to establish trust in that signature. Well, so the manufacturing process is what ensures this. So in the manufacturing process, a number of basically one-time programmable fuses, right? OTP fuses are burned to create sort of a bank corresponding to a secret seed. No one ever gets to see the seed, and the silicon ensures that, right? And then the manufacturer issues an endorsement key or endorsement certificate rather over a key that's generated from that seed. So unless you can come up with an alternate mechanism for establishing trust, like I described, you're not going to get away from what I believe you're considering the single point of failure. So what are the points of failure? Well,
Well,
Intel.
so if you can help me with the one thing that you just said there, what if that piece of silicon can be
Yeah,
fabricated in two facilities? One in
yeah.
Arizona under Intel's jurisdiction and unrelenting security controls, and
Mhm.
an exact electrical functional equivalent of that in, say, Vietnam. Not that we don't
Yeah.
trust our
Well,
partners
I
in
mean,
Vietnam, but we have.
ideally, so yeah, I was just gonna get into sort of all the things that can go wrong in that type of setup. So one, the chip design might be flawed, and usually the answer to that is you know, open design. So perhaps if you all follow ARM-CCA, or there's this project called Keystone that allows you to create your own effectively open source confidential computing hardware. So certainly Intel is not open sourcing their silicon design, so that's a possible attack vector. And the counter to that is reputation. So Intel, if they're discovered to have a backdoor, it is a big hole in their business. So there is that threat that they would need to contend with. So for the the signing key Intel uses to sign endorsement certificates certainly could get compromised, and hopefully there is a revocation mechanism around that, basically saying now we need to effectively recertify all the chips that we produced. And I, I haven't looked, but I would imagine I would design a mechanism like that into that.
Yeah, the
If you're
Blu-ray
talking
industry
about
went through about
right, if you're
3 iterations
talking
of
about a
that.
Vietnam factory versus a Arizona factory, I would certainly hope that they use different endorsement keys for that than the manufacturing. Again, the confidential computing in its pure form cannot survive without effectively openness. So you need open source design, you need open source manufacturing effectively, right? So you need and otherwise the only backstop for attacks would be a reputational damage, which I would
That's
imagine
very
is,
real. And in
yeah,
fact, when I overlay what I understand about some of the Web3 and blockchain things, it is in fact the reputation, the demonstrable identity, and the reputation of that identity in immutable ledgers
yeah,
that attracts me.
yeah.
But with that, I'm going to shut up and let you get on with your regularly scheduled meeting.
All right.
Thank you for indulging me.
Sure. Okay, so let's get started. So I'm going to share my screen. So Dan, John, Steve already added you as attendees to um, uh, the call. I'm gonna share my screen now. You should be able to see that. Okay. So I wanted to quickly update you. I didn't put that on the agenda, but I figured might as well. On how our governance patterns are starting to get used in sort of the real world application of these. So part of my full-time job, well, I guess this is also, but another part of my full-time job is the redesigning our, so my bank's controls architecture and sort of figuring out what the information architecture around that is, what the sort of architectural building blocks ought to be, and then the next step, of course, is going to be mapping our existing systems on that and all the the groundwork of migration. But towards that, remember how I said that there is these things called control objectives, and then there are control procedures, and so that's kind of the lingo of the industry. So there is this tool that institutions use called Archer that allows you to document all this stuff, and then if properly used, you can basically specify all of that. So the way so this document that I hope you can see, this is our verifier governance, right? So that's the first one I'm tackling. And so we have all these roles, and we have the assets, and all of this is good. And then we have the forces: trust and verifier, availability, performance, confidentiality, integrity, and then there is solution. So finally get into that. So let's take a look at this. So trust and verifier is established by the following mechanisms. So immediately, establishing trust and verifier is a control objective. Okay, so we have an objective that we should be able to trust our verifier, and then go down the list. What does it mean for us to trust our verifier? So this document already did the work for me. So as a basically a person in charge of figuring out, documenting, establishing controls at the bank to establish trust and verifier, I need to make sure that it's properly administered, so expected code, secure configuration, and properly administered hardware. So that turns into a couple of effectively control procedures. One is make sure that we know what the expected code is and what the expected configuration is, and be able to prove that. And the second one is properly administer the hardware. Now, this document doesn't say exactly what this means. That is something we translate into our domain. So then we need to establish processes for ensuring that we know what the expected code of the verifier is, what the expected configuration of the verifier is. And it's not going to be the same for us versus some other institution that may have their own processes. But at some point in time, I need to have a binary yes or no. Does it run in expected code with secure configuration, or doesn't it? And then I should be able to follow some evidence to prove to me that yes, in fact, this is what's going on. And there's a few things. So for instance, what information are you maintaining to prove that you know what the expectations are, and how you manage to map what you actually have to the expectation. And another part that's implicit but never stated in these documents is how do you actually test it? So periodically, you may want to do such a thing as stand up an improperly configured verifier instance, and then observe the fact that some mechanism prevented that from happening, and then log that, the result of that test. You may also specify we do this test every 3 months, right, or whatever. Right, and also we maintain logs, and then every time a verifier instance stands up and the expectations are met, that result is logged as well, right? And then you effectively create tools to make these observations easier. So like you basically encode all the expectations and processes in such a way that you can automatically verify that these expectations have been met. And then the further wrinkle on this, which is kind of interesting, is in an organization as large as ours, we will actually have 3 modes of a verifier. There may be a verifier that is a managed service, so Microsoft Azure attestation service. And in that case, the way we know that the verifier service, so this is not the tenant, this is the service, this is what Microsoft runs, runs expected code and secure configuration, is not something we're going to test. We don't know what those expectations are. We just simply trust Microsoft contractually that this is something that they will do. And the evidence for that might be, a yearly SOC 3 audit. And again, we, tailor the mechanism to the realities of the real world. Or we may say, we're going to stand up inside our data center a VMware certifier multi-tenant service, and we're going to administer it ourselves. We're going to manage it ourselves, and in that case, we have much tighter control over what's going on. And the third mode might be some team decides that no, none of those verifiers work for us. We are going to roll our own. So we're going to implement our own, unlikely, but let's say, or we found another verifier service that we want to use. I do not know, maybe Anjuna offers one. And then we're going to have to work, to figure out how do we meet these control expectations for that solution. Right, so these are all sort of the axes and the modes and the mechanisms that get employed. But the fact that this exists, I can be now sure that if I've done these the things like listed here, this control objective will have been met. How it's going to be met? Well, basically three, binary decisions, which I can then follow. Like double click on them and say, how do you know that this happened? Well, it's because we're using Microsoft Azure Attestation and we trust Microsoft, or it's because we rolled our own implementation and we surrounded with all the necessary controls, and here's all the evidence. Anyway, I hope that helps. I also hope maybe I will even publish a document around that to help folks design their services, like verifiers, like anything else that do in the computational computing world, to make controls possible, because oftentimes the facilities that we require aren't really there, and then we need to make compromises, but compromises ultimately come at the expense of security assurance. Or then we need to do what's called compensating controls, and that's usually a lot more expensive. So anyway, I hope you found that little intro useful. But that's sort of, if you ever wondered why these patterns exist and how they can help a real world deployment, that would be it. Any questions?
So you kind of tossed out, like, maybe for MAA or something like that, they could generate like a SOC 3 report. I've never looked at a SOC 3. Is there a defined list of criteria in that, or is it just sort of up to the auditor to put in whatever?
It's really up to the auditor. So
Okay.
I mean, certainly, SOC is Sarbanes-Oxley, so it's a a law, and one of our obligations is to ensure that our providers are SOC 3 compliant. Right.
Okay.
And then there is a yearly audit, and Microsoft works with auditors to ensure. And also, of course, we would have contractually an obligation with them saying, if you suffer a breach, you need to notify us. And then we will be listening on that notification. And if a notification like that happens, we should probably decide internally what the mechanisms are going to be, for us to deal with a reported breach of a service we rely on.
Okay.
So that's
So
also, yeah.
I was just kind of wondering if that would be another target for us. Like we wanted to get confidential computing into the cloud controls
We
matrix.
would need to, well, so I need to see exactly what SOC 3 uses. It's a sort of, because it's so broad, it's for the entire cloud service provider. I do not know if it has confidential computing specific language in it. Like, as you know how these regulations are written to be very, very generic.
Right. Right.
Right. So, but effectively, in some cases, you rely on a vendor for something, and then you're not doing your own examinations of their internal workings. You rely on the contractual obligation with the vendor and perhaps on some regulatory framework within the vendor operates to basically, sleep well at night knowing that someone else is doing the work. I guess that's what I'm trying to say here.
Right.
Yeah, but if we're gonna use, when we work this other hat I'm wearing is working with the cloud controls matrix at CSA. Well, there are implementation guidelines there that again, over time we're going to strengthen them to have more specifics and more precision in what does it mean to trust a verifier service, for instance, running in the cloud. So there are documents that hopefully resulted in some level of rigor. But anyway, so I just wanted to shine a little bit of light on this because people who don't work in this space like I do may wonder, what's the end game on this, and this is in fact what it is. So for verifier, there are probably going to be 4 control objectives. So verifier trust and verifier availability, ensuring that all verifier assets are protected, and that these are the system of records considerations, ensuring that we have a record of, or we satisfy the system of record requirements around security sensitive policies and controls that are in place there. Right, so this, and again, also understand that a customer may work with multiple very, very different setups. And have different control expectations around each. What doesn't change is that each control objective must still be met, within the domain in which it applies. Okay, so going back to reverse proxy governance. So I've done a bunch of work. I then realized that I did not keep change tracking on. That's probably also good because it would have been very messy set of changes, but this is what I've done. The problem is unchanged. The roles and the assets were unchanged, but the forces I rewrote to map and to match largely what the verifier pattern says, because again, reverse proxy is effectively a service. Okay, it may not be a root of trust service like a verifier, but it has same security and trust concerns and availability and performance, right? Your reverse proxy needs to be up or some application stops working. You still have your regulatory because, reverse proxy deals with actual customer data. As a result, we need to ensure, I don't know, things like logs must be redacted and go down the list. Security and privacy, this is where we're talking about our full and partial modes. So, maybe application level encryption for stuff you don't want the reverse proxy to see. So that goes in there. And again, system of record considerations, because your reverse proxy is not just a dump pipe. It's not a router. It is something that may execute policies. This is what we filter out. This is what we, the headers we add. This is what we redact, etc. And because these policies are in effect, the policies must be tracked in a system of record. Because again, you need to prove compliance with the rules. And solution then is still in draft form, but it follows the same thing in the verifier governance pattern. Look. You still have trust, you have availability, performance, confidential, integrity, several considerations. So you have 4 here, you have 5 over there. But they're written in much the same way. And again, in the solution, which I only started to write, and again, I welcome contributions, so I don't do all the work, but following very much the same language, a lot of it is actually copy and paste. This is where, for instance, under balancing security and privacy, we have the full break and inspect. I should probably change that. We're not using break and inspect here, so I need to either define it or whatever.
Then both the sub bullets as well.
Yeah, I understand. So I'm just going to put a highlight on it, and I'll remember to change that. Okay, so and then system of record configurations. Again, there was so much work done in the verifier pattern that this is sort of, that was fairly quick copy and paste. And of course, it needs to all be reviewed and completed. And of course, the governance expectation summary needs to be filled in and so on. But that's the current state. I don't have much more to show than this for this week. So I don't know, we may keep this meeting short, or I'm happy to go through some of this text and start editing it, or at least adding notes about what still needs to go where. Because again, that's only so much work I can do outside of these meetings as well.
What would be most useful for you?
Well, let's see. If I'm not mistaken, no one on this call is a reverse proxy sort of operator and expert.
That is correct.
Yeah,
I can vouch for
have
myself
them.
anyway.
I have them at work and I work with them and I talk to them. And I basically, so the kinds of questions I would be asking of these folks would be something like, what policies do you put on your various reverse proxies, right? So your web application firewalls and so on and so forth. Or how do you make sure that your proxies are GDPR compliant, right? So collect enough of that information, try to distill it and capture it into this document as well. And that effectively what ends up creating the text that we then go and present for approval, etc.
So yeah, I would definitely defer to them in terms of what are the issues with a reverse proxy.
Mm-hmm. Yeah, and that's that is fine, right? So I probably have to put a lot more work into the regulatory compliance. I want to actually understand, with all the PCI and GDPR and go down the line, requirements. What does the reverse proxy specifically need to concern itself with? I want to understand this application level encryption, like to what extent this is actually being used in the world. And I know to some extent it is, but again, how does it manifest itself in terms of, say, application design, and see if there is anything I need to be mentioning here, because again, I only want to mention stuff that results in control objectives, right?
Yep.
If there is no control objective around it, then I do not know, maybe mention it in some other venue or in some other document, or maybe a subsection of this document just for someone's information, right? System of record considerations are actually the same everywhere, so that's really not hard. Like whatever verifier does, this is going to be doing something very similar. So yeah, so it's a lot more work than it may appear, but I believe I got the top level issues down. Well, another thing that I want to talk about is we're actually, I can see the light at the end of the tunnel for governance patterns, which is a good thing. Like I don't want to, much like, a therapist should not be a lifetime addiction. Like this also should not be a lifetime process. Like we should write it down, be done with it, get to a point where we're happy, and then only edit things as as needed, as things evolve, but not have but other things that I'm hoping we're going to accomplish, but that have been sort of elusive, is try to now influence the work at NIST, start working with, like CSA has been sort of a success, I believe, because we were able to inject ourselves into CCM, and now there is an effort within CSA of sort of privacy architects getting together and talking about privacy enhancing technologies. And of course, that's confidential computing, but also fully homomorphic encryption and so on. So what has been elusive is trying to work with governing organizations to try and inject our sort of expertise into their outputs. So, and again, we've had a little bit of success, limited success with maybe ICO and with CSA, but that's another area where I can see us do work. I also want to pull up this document. Bring it over here. And I haven't looked at it. I noticed that this document exists, and I want to maybe revisit it right now. So let's revisit our 25 goals, because we're now, 4 months in.
Yep.
And I just want to take a quick look. So AIML, were perhaps another, it may be a good idea to create a governance pattern around inferencing and training. Right, so that may be something we can put on the backlog.
And the more time I spend with LLMs, the more I think it's different than kind of traditional inference and training.
Yes, I will even say this. So another one of my projects is information technology asset management. So regulatory obligations require that we keep track of all our assets, and we keep track of all our data. We actually know what data is, how it's classified, who it belongs to, etc. And the way it manifests even inside the, this confidential computing thing. So, for instance, verifier service, right? You're governing a verifier service. You actually need to be able to enumerate all your verifier service instances. And if there is one that is present but is not accompanied by the controls that you demand of verifier instances, that is in fact a breach of your regulatory obligations. So, right, so why I'm saying all this, machine learning models turns out to be another type of asset. It's not a database, not a file. And it's another type of asset because it has its own control mechanisms and its own processes around them, etc. And another interesting one is the AIML is one area where you cannot write your code based on synthetic data. Right. So normally you have a firewall saying developers don't get access to production data. Right. So when the developer writes your code for transferring your money from one account to another account, they don't need access to your, like Steve's or Dan's account to be able to write and test their code. Well, machine learning is different. You actually need production code in which to train your models, but that gives developers access to production data, and there is no way around it. So that ends up causing, a kind of a fairly significant change to the controls ecosystem. So confidential computing can perhaps help, with actually easing your controls burden by saying, if you actually know which tools you're using on your now production data that you pulled in to train your models, that itself has controls around leakage, so you don't just have an ability to just dump it uncontrollably and leak it, and now you need a data leakage prevention firewalls, but you can actually use trust execution environments to control what code gets to access to that data. So that's one possible idea in that space. So I think after reverse proxy, we should probably tackle this.
Okay. Yep.
Yeah, and I'm gonna change now reverse proxy. Bring this back. Okay, so I'm gonna accept this change here. And again, what else just means if you can think of another thing for us to accomplish in the governance patterns, business specifically, that's the placeholder for that. Okay, contributions to CSA CCM 4.1. We are on track. So the the work is ongoing, and the changes to control specifications have been made. They are not the platonic ideal just yet, but it's actually very important strategically to ensure that human and non-human identities get harmonized, because that's going to be a huge boon to confidential computing, and this is through the trustworthy workload identity work. So that's a bit further out. But the fact that the guidelines now demand it means that confidential computing will have an easier time in the marketplace because with workload identity in place, it's much easier to harmonize how you govern human and non-human identities. Okay. So governance around confidential workloads. What did I mean by that? I think that's really identity governance. Yes, that's I need to basically say trustworthy workload identity SIG started separate from GRC, but there'll probably be some crossovers. So, for instance, with reverse proxies, how workload identity traverses a reverse proxy will probably be a subject to discussion inside the GRC, but it's largely an independent effort. It has more to do with attestation than governance. Shared responsibility model. That would be a good third quarter topic where we need to, and this is, by the way, shared responsibility model will fall out from our, remember this other document we have? My cat is being very annoying right now. Move. Then this is in the governance patterns. So again, we are really cutting edge in our group for this work. And I can tell from like being involved in all sorts of other governance things. But this matrix right here that we have in this is in the approved folders pattern, but it's really not approved yet because it's we're not like it will be the last document to be finalized because it depends on everything else being finalized.
Right.
Right, but that is your shared responsibility model. That at a glance will tell you everything about who is responsible for what to whom.
Yep.
Right. So, and it would be good to see what the prior art is. That I have not even started, but the output of governance patterns will be contributed. So that's going to happen, right? And I do not know why I put rollbacks attacks on storage. I guess, yeah, that's important because that's one thing confidential computing has no way of assuring today. And that is if you operate on stale data, it's very, very difficult to detect. But we may want to consider mechanisms for doing that. Again, it's a discussion for another day. And then publishing the results would basically mean publishing our matrix and any other decisions we make in this space. And this is where we could, so the Cyber Resilience Act out of EU, NIST. I think MITRE is going to be the, oh, hi, Mari, we're just talking about that.
Hi, guys.
Hi. So we're talking
like Lenny and Squiggy.
There you go. We were just reviewing our 25 goals, and we already talked about we need to complete the governance patterns, which means at this point completing reverse proxy and starting and finishing the AI/ML space. And then we talked about other things here, but when it comes to cooperating with and contributing to other organizations, this is an ongoing conversation that you've been involved in here. But what confidential computing governance and MITRE have in common? So you have attack, you have defend, you have others, which I'm forgetting probably. But I would love to have an output this calendar year where MITRE starts reflecting some of the attacks on confidential computing and some of the defenses that confidential computing can offer. And you're probably best positioned to drive this, like not me, but I'm very much am very hot for that idea.
I've seen the attack framework. I guess I wasn't aware of the defend. Is that
Yeah.
is that
There is
similar
MITRE detect too, right?
Detect, no, I don't
No,
think
no.
there's a detect.
There is a attack and defend.
Attack and defend, there, we have perception, we have a bunch of models.
Yeah. Well, that's the thing. Like, we don't need to boil the ocean, but
Yeah.
maybe start with how confidential computing can help defend you against attacks, right?
Yeah.
And start putting recommendations there. And also because we're worried about confidential computing itself, opening avenues for attacks to basically start putting things around, like, how do you know that your confidential computing environment is secure?
Yes. Yep. Good. I like that. And I think we can start with Steve's paper. He did a threat analysis. Yeah, Steve, I think I need another copy of that. I'm not sure where that got put it.
Yeah, that's the one we did on the MITRE threats a long time ago.
Yeah. I'd be able to update that, but I'd like a separate confidential computing based threat model. The other thing we have, yeah, we have the CSA caveat where we're actually developing predictive threats using AI, and we're coming up with really good results. So we might be able to employ that too.
The
So
Atlas framework is also I mean, it's like attack, but it's focused on AI. So that might be
Yeah.
up there in the priorities.
Yep.
So, Mari, I would ask you to drive this. I have no further bandwidth between chairing 2 SIGs and also doing the CSA operation and my other daytime work. This is something that must be done. I do not have the bandwidth anymore.
So does that mean I have to conduct meetings like you do?
Or just take a meeting 1 week and run it. Yeah. Or just bring your topic to half a meeting, whatever. It's just like figuring out what the tasks are, figuring out what the schedule is, and what the deliverables are, maybe authoring some content. Like similar to what I'm doing here. It's just, I still need to get reverse proxy wrapped up. There is a boatload of trustworthy workload identity stuff that we're still doing, and the ITF prep. Like, it's becoming a big chunk of my day throughout the week and weekends now. So I can no longer take on additional tasks.
Yeah, I'm happy to take that on. I've been wanting to do that for a long time anyway. I've been wanting to extend and revise Steve's model anyway, and add some of my own stuff.
Yeah. Okay, so we'll then resolve to wait to hear from you on that. And
Okay.
if I don't hear anything for a few weeks, I'll ping
Steve,
you
I'm
again.
going to call you.
Yep, no problem.
Okay.
Okay. So, all right, to recap today, I started by explaining how the governance patterns we're already publishing are influencing how the control ecosystem is getting designed and deployed. Sorry for those of you who missed that introduction, but I will be writing up a paper on this because I'm also designing a controls architecture for the bank now. So it's going to, there is no need for that to be secret. The second thing we did a quick update on the reverse proxy governance pattern, which I'm still authoring now, because I'm the only one on this call today that actually deals firsthand with governance. I will be doing that, most of that, because I'll be now talking to folks who deploy and govern reverse proxies and their various regulatory and controls considerations around those. There will be an update on that. We quickly look through our 25 goals to figure out so basically decided that after reverse proxy is done, we'll figure out how to govern machine learning, so inferencing and training. And the latest one was the MITRE updates that Mari will drive, and that will make for very full 25 for us.
Oh, wait, are you talking about the stuff I sent you the other day? The assurance? Yeah.
No, actually, remind me what it is you sent me. I may have missed it or just flagged it. I'm like drowning in email.
Yep, I provided a model for machine and workload identity assurance.
Which email did you use to send that? Because I have multiple.
It was a Gmail, definitely.
It was Gmail?
Yeah.
I have nothing in my Gmail mailbox from you. I apologize.
Okay. Just 1 second. Novak, right?
Yeah, Mark Novak, Mr. Mark Novak at gmail.com is my email.
Oh no, it was outlook.com. I'm sorry.
Okay, hold on, let me see. Yes, I see that email from you.
Okay.
On Friday for 18. I have not yet looked at it. I now flagged it and will look at it. So next time we talk, I will have reviewed it.
Okay, I called it workload identity proofing and machine identity proofing.
Great. Yes, I see those attachments. So yes, I see this, and I will look before by next time we meet.
Okay, sweet.
Great. All right. With that, unless there is something else that you guys want to raise, I will wrap this up for today.
Great.
Well, if you have a few minutes, I can
Yeah, of course.
Go ahead, Steve. Sorry.
Oh, I was just saying, thank you, Mark.
Yeah, thank you, Mark. I wish you had more bandwidth. We'd all be happy if you just kept leading everything.
Well, it's a labor of love, but there's only so much love I can give. So,
yep.
Okay, so yes, you were saying.
If you want, I can spend a few minutes, maybe go over those models.
Yeah, let's do it. Absolutely.
Okay. Okay. Let me share what I have here. Let's see. Oh, you cannot screen share while the other. Okay, so you have to unshare, I guess.
Yes, I will do that. Let me do that right now. I'm just updating our attendee list. All right, go for it.
Okay. I want to find the email. Let's see. Now let me just do my screen. Shoot. Okay. I shouldn't be sharing everything here. Here's the email I sent. Okay, here it is. So the notion is MIAL and WIAL for machine and workload, modeled after the, let me just expand this a little bit. Oh, hey, stop that. Oh, I wanted to make it bigger. Modeled after the NIST 863A, which talks about identity assurance, but and it gives you these levels of sort of strength, IAL1, IAL2, and 3. But it's all focused on person. So what I said was, well, this could help in a governance construct. And when you go to verify, could be inputs for the verifier, or could be practices, governance practices of the verifier. So let's just do workload, because that's the, what? Oops. Okay. That's the sort of the more important one. And so the notion is, if we can come up with what it means, to have, hold on, let me see where I went here. Okay. So for example, in the workload, the runtime attestation is something we really haven't talked about. How do I verify that workload from the running code base? So I did try to tackle some of that, but so here's, for example, is this model. And the notion of, what would workload identity assurance level 1 be? Well, it would just sort of be, not a whole lot of formal governance. You're sort of taking what you get from maybe an attestation service. And, maybe the cloud provider says it's the workload that you posted. Okay.
So basically, what Whimsy does today.
Yeah. Yeah, that'd be a good thing.
Yeah. So basically, like you may also talk about credential binding here.
Yeah.
So if the credential is not strongly bound to the workload, that
Okay.
is probably not going to be very strong at all.
Right.
Right. So I agree with unattested,
Yep.
and I would then also put, yeah, if your credential is not strongly bound to the workload instance, then you don't really have. I mean, you have an identity.
Yeah. Yep.
But you don't really have
Yeah. So I think
any assurance around it.
Yeah, I think WIAL2 gets to that binding.
Yeah, this is, by the way, what AWS basically, there's a metadata service. And
Okay.
this is how Spiral works on AWS. Is basically the node attestation thing says, oh, Amazon says you're running this instance, and you don't really need attestation for that. But it's, it is what it is.
Yep. And then, I think this, the hardware attested, I think sometimes it gets a little bit tricky. Because I don't see necessarily the hardware key being used a lot. I see more the provider key. And this is where we want to get, right?
So let's probably separate this into two. So there is the so say you're using TPM.
Yeah.
So if you're using TPM and it's a virtual TPM,
Yeah.
then it is not a hardware key.
Right.
Right, a provider key. Now I can split hairs further.
Yeah.
Google, I believe, knows your virtual TPM key, manages it for you. I think Microsoft is trying very hard not to. Certainly, that's how I was the one designing a virtual TPM for Azure, and that's I believe slightly better, but still, loosely speaking, you can say it's not a hardware key. It's a software key.
Right.
Now, with trust execution environments, it's always a hardware key.
Yeah.
So, and then further, if your identity has claims about the workload, but also about the hosting platform. So, this is my payroll application and it's running in Germany. The payroll application, if it's running in a T, will be hardware tested. And the location will be a statement from the cloud service provider, which is not the same level of assurance.
Right. So then back to our verifier governance, right? I think it implies some things for the issuer and verifier. And maybe these might be things we'd work into those documents that we recently put together.
So this is more for workload identity thing, right? Or are you thinking about this more of a governance thing? Like, I guess it's both.
It kind of relates, right?
It's both, right? It's one is how you establish it, and that's the workload identity group, and another one is how you think about it and what governance leverage you attach, and that would be this group.
Right. Yeah. Now, I did want to take a shot at, come on, oh, it's blurry, integrating the SBOM and understanding how that might play in it.
So I can tell you. So are you in the trustworthy workload identity conversations?
I don't know.
Well, you should be. Tuesdays, 6 a.m. Pacific.
Sometimes.
Okay, so very quickly on that. So what makes workload identity trustworthy per the specifications we're putting together is that it has provenance. And the provenance starts with an identifier. So JTI tag in a JOT or SVID ID, SVID unique identifier, I forget what it's called, in Spiral, but it's a breadcrumb. And from there, you can say, okay, this unique identifier that only this credential has, I can then go to some log or to some credential issuer and basically say, hey, what is, what caused you to issue this credential based on this ID? And then it can tie you into SLSA, so Salsa or in Toto, and you can basically get down to the SBOM. And we're still defining those mechanisms.
Yep.
But we are thinking about that, yes.
Oh, good. Okay.
So
Okay,
please join those conversations then, because that's where that's all going to be decided and documented.
Right. There is sort of another concept of embedding a secret in the dynamic runtime, so that I can go beyond an SBOM into what might be something reasonable. So for example, in AI, what we're seeing now is this notion of embedding secrets in the data or secrets in the code, so that when you ask the LLM a question, if the code hasn't been corrupted, you get only a certain answer. And that's one way you know it hasn't been corrupted. I just wonder if there's something we could do to assure that, what we have a problem with drift in the runtime. And so it's one thing to say, yeah, well, I have pedigree on the SBOM, and I know it's using my immutable image, but oh, maybe it's been attacked over the last couple hours it's been operating.
Right.
And how do I do that? So I think it would be good if we could spend some time on dynamic attestations.
Yeah.
And what that means. So I tried to take a little bit of a shot at, what that might mean, but I don't have a good solution per se for it.
I've given this some thought, not enough to offer you a final solution, but this is a conversation that I am, quite happy to have. I do not know what the proper form is. Maybe attestation SIG might be a good, they will meet 2 weeks from yesterday next. So maybe email the attestation SIG mailing list and put that on the menu for that call. But yes, or maybe you and I can have, I will literally need to jump in 1 minute because I have another call starting. But
what I was hoping is maybe post these files somewhere that folks could get to them and just see what people think. Is that useful?
Yeah, you can definitely put them in the GRC folder in Google Drive.
Okay. GRC folder.
Did you have access to it? If
I don't
not,
know.
I'm just gonna put it in the chat.
Give me the chat.
If you don't have access, request access. Maybe make a folder for yourself. But yeah, put it in there, and we'll talk next time. But I really do have to go now.
Yeah, no, perfect. Sounds good.
All right. Take care. Well, fantastic. Thank you so much for joining today.
Yeah, awesome.
All right. Bye-bye.
Bye-bye. Hey, Mark.